Hey guys, so our last two sections for this unit is we've been practicing solving equations and solving inequalities. So now we're not only going to solve them, we are also going to create them. All right. These next few pages in your packet, it starts like this, creating and solving equations. And I think it goes on for a little while. I think there's one, two, three, there's 5 pages of this. We are going to do about half of these during this notes. Then we're going to do the other half of them in class on Thursday. So my B-Day people, if this is super not making sense to you, then please tune in tomorrow so that we can make sure it makes sense for you. All right, so let's get started. Let's start with some straightforward ones. It says find two consecutive integers whose sum is 67. All right, so we've got two integers. We've got the first integer and we've got our second integer. All right, they are going to add up to be 67. So we've got to figure out a way to create an equation with this. So your first integer, what you start with, could start off as your x. All right, and if it's two consecutive integers, let's just say we have 7 and 8. All right, consecutive integers there. 8 is 1 larger than 7, right? 7 plus 1 is 8. So if you start with some random x, the way you get to the second consecutive integer would be x plus 1. All right, gets you to the next consecutive integer. All right, so those are our two integers, and we know that they are going to add together to add up to 67. So if we write out our equation, x plus 1, right, adding our first and our second integers together, equals 67. All right, so now we need to solve for x. So we have 2x plus 1 equals 67. Subtract 1 from both sides. We're left with 2x equals 66. And then divide by 2. We have solved for x to be 33. All right, but it didn't ask us to solve for x. It asked us to find our first and our second integers. So if we go back to how we started our first and our second integer, our first integer was x, so our first integer is 33. Our second integer was x plus 1, so our second integer would be 34. So our final answer would be 33 and 34. All right, make sure you don't just, ooh, that looks weird. Let me try that again. Make sure you do not just stop at finding x. You go back and make sure that you're actually giving the answers from what they have wanted, what they were trying to find. So number 2 is similar. There is one key difference here though. It says find two consecutive even integers whose sum is 14. So once again, we're finding two different integers, our first number and our second number. All right, you can always label your first number as x. But this time when we go to even, think of even if we do 4 and then the very next even integer being 6. How did you jump from 4 to 6? We had to add 2 because we're going by evens, all right? It's not the most consecutive one, it's that even integer. So our second integer would be our first one plus 2 because we've got to jump up to the next even integer. All right, now that we have that set up, we can set up our equation. We know these two are going to add together to equal 14, whose sum is 14. So now we can just solve. So 2x plus 2 equals 14. Subtract 2 from both sides. 2x equals 12. So x equals 6. All right, remember we wanted our two consecutive integers. So if we come back and plug it back in, we have 6 for our first integer. Then 6 plus 2 is 8. So we have 6 and 8 as our final answers there. All right, I'm going to kind of jump around so we can get a few different perspectives here. Let's see. We'll actually just go to, let me go to 3, just so that we can kind of see this. All right, it says the sum of 2 consecutive integers, again, so pay close attention to that, 2 consecutive integers, is less than 29. All right, there's a difference there, is less than 29. Find the pair of integers with the greatest sum. All right, so we still have our first integer and we still have our second integer. All right, our 2 consecutive integers, we can still start with x, and x, we can go back to x plus 1 because it's our consecutive integers. But this is where things are going to change, is the setup. All right, these no longer equal to a number. We are trying to be less than 29. So when we add these together, x plus 1, we need to make sure that we put that inequality sign of less than 29. All right, so now we can solve. We have 2x plus 1 is less than 29. Subtract 1 from both sides. 2x is less than 28. And then dividing by 2. X must be less than 16. Sorry, my bad. No, not 16. What's it, Daisy? 14. That's where we're at. So x must be less than 14. So when we are finding these 2 consecutive integers, all right, x must be less than 14. So go down to the integer that's right below 14. So x could be 13. So as our first integer could be 13, and our second integer could be x plus 1. Our second integer could be 14. As long as x is not 14, our second integer could be 14. So we would have 13 and 14. All right, so let me see which other one we're going to do. All right, so let's look down at number 7. This will be the last one from this grouping. All right, it says the length of a rectangle is 5 centimeters more than the width. The perimeter is at least 54 centimeters. What are the smallest possible integer dimensions for the rectangle? All right, y'all know me at this point. Y'all know I am a visual person. So here's my rectangle. It says the length of the rectangle is 5 centimeters more than the width. So I'm going to go ahead and label my width as W because that's going to be constant. And the length is 5 centimeters more than the width, so we could do width plus 5. All right, so I've labeled my rectangle. It says the perimeter is at least 54 centimeters. All right, so if we go ahead and set up our perimeter, if remember, perimeter is adding all the sides together. So if that's W plus 5, the other side is W plus 5, and this one's W. So W plus 5 plus W plus 5 plus W plus W. All right, for this one, it is at least 54 centimeters. That means it can be greater than 54 centimeters, or it could be equal to 54 centimeters, but at minimum, it is 54 centimeters. So this could be greater than or equal to 54. Our perimeter can be larger than 54, but at least 54 centimeters. All right, so now we need to combine our like terms and add. So we've got 4W plus 10 is greater than or equal to 54. Subtract 10 from both sides. 4W is greater than or equal to 44. So W is greater than or equal to 11. It says, what are the smallest possible dimensions for our width and our length? For width, since it has to be, our width could be greater than or equal to 11, our absolute smallest thing for that width is to be 11. All right, then we can plug that in for our length. 11 plus 5, because remember this right here is our length. So 11 plus 5 gives us 16, and those are the absolute smallest dimensions for our rectangle to be at least 54 centimeters. All right, so we'll do the rest of these in class. We're going to go ahead and head over to this one that says creating and solving equations involving distributive property, which means we're going to have a lot more going on in these problems. Okay, so let's read through this. Aaron and Alice are bowling. Alice's score is twice the difference of Aaron's score and 5. The sum of their scores is 320. Find each student's bowling score. All right, so we need to choose a variable for the unknown quantity. You can kind of just do whatever you want to. So let's talk through this. All right, so if we're thinking through this, you kind of want to think about whose score are we talking about in relationship to. So we're comparing Alice's score to Aaron's. So Aaron's is almost like our starting. So I'm going to put Aaron's as an A, and then I'm going to create Alice's score based off of this description. It is twice the difference of Aaron's score and 5. So let's kind of start within the middle. The difference of Aaron's score and 5. So we would do A minus 5. All right, that's the difference between Aaron's score and 5. And then we want twice that. So we're going to have a 2 on the outside of that. All right, so then if we're trying to figure out, we're writing an equation to model this, we know the sum of their scores is 320. So we would add these two scores together, A plus 2 times A minus 5 equals 320. All right, and then we're gonna, y'all see our little chart here. So we're going to go ahead and fill that out. Our initial equation is A plus 2 times A minus 5 equals 320. All right, our first step is to distribute that 2. So we'd have A plus 2A minus 10 equals 320. So that's distribution property of equality. All right, next after that, we are combining like terms. A plus 2A gives us 3A minus 10 equals 320. I'm going to shorthand this to CLT, combining like terms. All right, next we are adding 10 on both sides with our addition property. So we have our 3A equals 330. And then lastly, we are dividing by 3 on both sides with our division property of equality. Property of equation, sorry, where A equals 110. So then we need to explain this a little bit more. Based on our solution, what is Aaron's score? So we need to plug this back in. So Aaron's score was just our A value. So that means it's 110. Now Alice's score was our 2 times A minus 5. So we need to plug in our A value that we just found. So 2 times 110 minus 5 will give us a total of 210. And those would be our final answers there. All right, let's try another one. Let's look at number 2. So Mari, Carlos, and Amanda collect stamps. Carlos has 5 more stamps than Mari, and Amanda has 3 times as many stamps as Carlos. Altogether, they have 100 stamps. Find the number of stamps each person has. So if we're looking at this, we notice that people are almost in relationship with in terms of Mari. That's kind of where our starting point is. We are not told anything about Mari's score individually, or her number of stamps, I'm sorry. Still stuck on the scores from the last one. So we're going to keep Mari as our variable as M. All right, and let's kind of work off of that, us knowing that about Mari. So it says here, Carlos has 5 more stamps than Mari. So if he has 5 more stamps, we take Mari's number of stamps and we add 5. So that gives us Carlos's. And then later it says Amanda has 3 times as many stamps as Carlos. Well, we don't want to add in a new variable. We want to keep with the same variable m. So Carlos's number of stamps is m plus 5. So if Amanda has 3 times as many of that, we could write that as 3 times m plus 5. Because m plus 5 is Carlos's number of stamps, and we're just going to multiply that by 3. All right, and then it says altogether they have 100 stamps. So if we were to model an equation with this, we have m plus 5 plus 3 times m plus 5 equals 100, since they are all adding together to be 100. So then we would solve that together. So we put that together and solve. It's on the next page, so let me kind of pause this while I transition to the next page. There we go. So we've got our initial equation. Step 1, we're going to go ahead and distribute. So m plus 5 plus 3m plus 15 equals 100. It's our distributive property. All right, what's next is to combine like terms. So m plus 3m gives us 5m, and then 5 plus 15 gives us 20. Combine like terms. All right, next is going to be to subtract our 20 from both sides. So we have 5m equals 80. So that's our subtraction. And then last but not least, we are dividing by 5. So our m is going to be, if you do 80 divided by 5, what does that leave us with? Should leave us with 16. So that's our division property of equality. All right, so if we go back to this, all right, remember, based on your solution, how many stamps does Mari have? Mari was m. So Mari has 16. Going back, Carlos had m plus 5. So we have 16 plus 5, which gives us 21. And then Amanda had 3 times Carlos's m plus 5. So she would have 3 times 16 plus 5. So 3 times 21, which would give us 63. All right, so that's where we're going to stop with these notes. It's already getting to kind of a long video of 18 minutes. If you would like to go ahead and start some of these individually just to kind of see how you're doing, that is fine. But we are going to be going over the rest of these problems in class together as a full group. All right, let me know if you have any questions about any of this when we return on Thursday.